Excellent. Welcome, everyone. I hope you can all hear me loud and clear. I'm going to present today on the engineering and technology career with an engineering diploma, bachelor or master degree from the Engineering Institute of Technology, EIT. So I'll get started, and if you're all ready, I'll move on. So first of all, about myself, I'm Steve Stain. I'm the Deputy Dean of Engineering here at EIT. I've got a master's, bachelor's, professional, and I'm also a professional project manager. I've got experience in electrical, electronics, software, mechanical, and industrial automation, and a whole heap of other engineering aspects. And I love engineering. I'm passionate about it, and it's something that I believe the world needs more of. Now, I'm quickly going to run through a few topics today. I'll be talking about EIT, or Engineering Institute of Technology, some of the benefits, program structure, classrooms and labs, and how that all works. Also, I'll touch on some of the accreditation and pathways from other qualifications. And then I'll get into the nitty-gritty of the bachelor's as well as the master degrees. And then I'll have some time at the end for any questions or answers from my side, and any things you might like to add from your side as well. So EIT, or Engineering Institute of Technology, has actually been around for quite a while. Its sister company, IDC Technologies, has over 500,000 participants over the past 25 years. And from that, the Engineering Institute as an engineering qualification giving entity was born. Now, EIT provides a lot of degrees, bachelor's, master degrees, as well as advanced diplomas and a few other vet sector or vocational sector courses as well. And it's all based on the latest online technologies in engineering. We've got almost 300 highly experienced instructors, some based in London, Perth, New York, Sydney, Houston, all over the world, even in Kalgoorlie, which is a little tiny town here in Australia. And we've got students in over 120 countries around the world, so it's truly global, and it's job-focused, and it's practical job-focused courses from an award-winning company. Now, this picture is quite important because it states that opportunity can go past so quickly that you can be left behind, and EIT strives to ensure you do not get left behind, but you're actually in the driver's seat of that train, and even more so in control of your own future and destiny. So be sure to jump on board the hype train, which is engineering and the technology future, and make sure you secure yourself and become future-proof. So we are leading the engineering and technology education by using online and interactive delivery methods. So some of that I'll touch on as I go through the slides here. So we've contributed to engineering and education training to students in over 120 countries, as I mentioned earlier. And quite interesting, a lot of our students are based or age range between 25 and 60 years old, largely male dominated, which is something we are trying to change. We are aiming to get more female engineers and technologists in the field and out there. What's also interesting to note is we've got a pretty equal split between international and Australian students. So it's a truly global experience, and it's a great way because that way you interact with not only students from your own country, but also build up connections with future business partners globally. So it's a fantastic experience. Now, we offer a whole heap of courses ranging from short 3-month professional certificate courses to advanced diplomas, bachelor degrees, graduate certs, all the way through to master degrees. We've got degrees in industrial automation, electrical, safety, mechanical, and civil degrees. Mechanical and civil degrees will be launching early next year, but we've got a whole range all across the engineering field. Even in oil and gas, we've got a whole bunch of courses there as well. So it's quite diverse. So the question is, what is in it for you? So before I start on this slide, I quickly want to try something. and send to you all a quick video, which I found is quite useful in inspiring engineering in self and colleagues. So what will happen now on screen? You'll see in the next minute or so a video playing, and it's important to just ensure that you switch back to the whiteboard tab once ready. So in 1 second, here we go. Your tab should automatically switch to YouTube, and you should see a video playing. So once the video has stopped playing, you can switch back to the whiteboard, which is in the top right-hand side. You'll see next to the webcam, there's a little sign for the whiteboard panel. You can just switch back to the presentation. So hopefully that was quite inspiring. I get really excited when I watch that video because that shows you what engineering is about. It's all about taking something that's there, making it better, and automating the future, and making lives easier for everyone around us. So what's in it for you then? Why should you want to become an engineer or a technologist or even a specialist in your field? It's because we can help you get there by providing practical, industry-oriented, job-focused units, uncompromising high quality and standards. You get highly experienced instructors. Those have instructors that we use and lecturers that we use have all been in industry. They know what they're talking about. They are pros. And it's truly online. You can study from anywhere, home, work. You can even do the practicals from home work. It's fantastic. And you also get an accredited degree and qualification from the Australian government, TEXA, and it's globally recognized by many bodies and in industry bodies as well. And we've got a continuous pathway for you to start all the way from trade through to master's degree and even in future doctorate degrees. So we've got the whole range set up for you. We've got a good reputation and value for money, worldwide coverage. What's great, we've also got high quality resources with an online library. It's a massive library and it's 100% online and 100% available to you as students. And you've got multiple attendance options with multiple sessions at different times. And you've got a dedicated learning support officer, a person that will go with you on this journey throughout your studies from the start to finish. You will not be left alone at all. And that is extremely valuable to us, that you always feel that you have the support and that you know that you have the support, and we provide that. That altogether drives for low attrition rates, which means students who start the course end up finishing the course, and that's very important to us. So as an engineer or technologist or specialist in your field, you can go into electrical, for utility mining, mechanical, manufacturing, product design, automation, civil, and many more. Any suggestions on what other job prospects or fields are out there in engineering? If you've got a few ideas, feel free to type out in the chat space. I'd be keen to get your input as well. What other fields do you think engineering touches on or revolves around? Any ideas, any suggestions? Delanya, Ree, Shanae, Carol? Feel free to type it out, or aviation, that's it, IT, yes, engineering does go into IT, and aviation definitely, So aviation entails not just a single field of engineering, but that's actually quite complex because you've got the mechanical, you've got automation, aerodynamics, thermodynamics, the whole works in there. It's a fantastic field. Medical, definitely. Medical, biomedical engineering, that's a massive research space currently, with all prosthetics and robotics all coming together. You can just listen to an Elon Musk video and you know all about the medical future that some engineers are talking about. It's fascinating, So those are all prospects for engineers, technologists, master's students, as well as doctorate students, and trade students as well. Engineering is so diverse that you can always land a job somewhere in engineering. And what's even more so is it cultivates a way of thinking so that you can move from one field to another if need arises, because the world is ever changing. Artificial intelligence, that's a massive engineering field as well. And that touches on the IT space that Charnay mentioned earlier as well. So those are all parts of the engineering prospects out there. So what I'll do is I'll quickly go over some of the program structures, and I've got a few slides on that later on as well, so I won't go too much depth here. But we've got electrical engineering, industrial automation, industrial IT and communications, got mechanical engineering, such as the aviation part that Bruno mentioned. We've also got chemical process engineering, oil and gas, civil engineering, and a whole range of other certificates and advanced diplomas. I'll get to that in a few slides coming up. So just a note again that some of the strengths of EIT is the resources, lecturers, international connections worldwide. I mentioned entrepreneurial response time is really quick, got a good track record, and quite a lot of students globally. But what's interesting though is the way our classes are scheduled. It's flexible in the sense that you can hop onto a session that works for you, but it's also inflexible in the sense that you have to attend classes in certain courses, because if you don't attend the class, you might miss out on the actual content that's being delivered. So it's live, online, inflexible learning, and that's a very important part of it, because if you're just given a video to go and watch in your own time, life sometimes gets in the way and you might not get around to it. So it's really important to us that our students attend classes. And you've also got the learning support officer, which I talked about earlier, which is someone there to help you along your journey. So e-learning, and this is how it's being delivered. And today's session is a good example of that. And that is a virtual classroom. A space like you can see here, where I can either scribble notes, as you can see on the screen. I can type out information on the screen as well. And all of that is there to assist you in learning. So this is the virtual classroom space. You've got the whiteboard, you can talk to me, I can talk to you, you can chat. It's a fascinating space. I can share my screen, my desktop screen with you all. You can see if I want to demonstrate some application in MATLAB or the simulation in SolidWorks, I can do all of that using this virtual classroom. It's even great, supported by this is also assignments. So all your assignments are online and or paper-based, but you can submit them online. And we've got a whole platform assisting you to ensure that you know which assignment is due when and helping you along the way. The course is also structured in such a way that it's easy for you to follow, to know which module or units to take next and what prerequisites there are. It's really made to ensure your life is made as simple as possible during your studies. So the presentation format, as I've explained, is pretty much how we use the whiteboard space here. You can ask questions. We've also got a little pop quiz thingy that you can use. So it's very important that we constantly get feedback from our students during sessions. So today's session is a little bit one-sided from my side, but it's important to also get some information and input from your, it stimulates thinking as you progress. And we've got a whole heap of tools available to instructors and students, allowing for interactive discussions. So engineering labs, that's one of the questions we get asked a lot, is engineering is practical. How do we solve that problem? So any ideas as to how you can solve engineering labs via an online platform? Any ideas there? Reed? Dulan? Charnay? Carol? Any ideas as to how you can apply practical engineering labs using an online space? Doing practical assignments, maybe? Yes, that is. Definitely doing practical assignments on the computer. That's definitely one way of doing it. And Carol says remote labs accessible over the internet. That's good. And simulation software. That's true. So all three of those answers are exactly what we are doing here. We combine practical assignments with simulation software and remote labs accessible over the internet. What that means is you're given an assignment to complete. You're based, say, in the UK, and part of the assignment says you need to log onto a computer with a PLC simulation and real PLC hardware connected to it. You then program what you need to program on your computer. You upload that to the remote computer by connecting to the remote labs, and you can actually see the hardware and your software running on that lab. So instead of you having a physical lab in front of you, all you do is you connect remotely to that lab. It's the exact same experience as if you are walking into a computer lab somewhere and sitting in front of a computer, looking at the hardware, playing around with it. Only difference is you're sitting in your bedroom. And that is the beauty of remote labs. So it allows for, I'll show a few pictures on that later on, but it allows for operating it in real time, and it's a pretty accurate representation of the current industry, meaning most appliances or devices or equipment in industry are all connected to the internet in some form. So it's a real representation of what you get in industry. And it's pretty straightforward to interface with the equipment. You can access it anytime, and it's pretty safe because you can do a lot more with simulations and in a simulated lab environment than you would be able to do in a real workplace, because you don't want to go and blow up someone's PLC device. In a simulation, you can blow it up a few times and reset it, and boom, you're ready to go and try again. You make a mistake in the code here, your program freezes up, you just press the reset button and you try it again. That's the beauty of it. And there's no barriers. You can do it globally. Bandwidth is quite important, and that's important to note here as well. Because you're accessing a computer remotely, it's important that you have sufficient bandwidth to run the remote labs. It's not too onerous, but it is important that you have at least a 1 megabits per second internet speed. Here's a photo of some of the hardware, and what you do is we connect a webcam to the remote lab so that you are able to program whatever you need to program, and using the webcam you'll be able to see the LEDs flicker or the readings on the device depending on the level, etc. So that's all part of the remote labs that you get access to as part of your course. An interesting note about our accreditation, as I said, we're with TEXA. We're also with the Dublin and Sydney and Washington Accords. We're working with Engineers Australia here in Australia with all our degrees in order to get them accredited for international recognition, and a whole range of our degrees are already recognized by these bodies. ISA is one of them, and a few of the other bodies listed here below are also quite fully aware of what we are doing. That ranges all the way from New Zealand, South Africa, Canada, all the way through to New York, and even local universities here in Australia. They're all in partnerships and affiliations with us with articulation pathways, etc. So now let's get to the good stuff. We've got a certificate degrees, diplomas, advanced diplomas, and then bachelor, graduate diploma, and master degrees. So today I'm just going to talk about the bachelor degrees and the master degrees. And then I'll be finished with these slides, so it's not a lot to go. So this image in particular is quite important because it shows the various pathways into our degrees. So let's say you're a high school graduate and you wish to study with us. Pretty easy. You go straight into the BSc degree and you can study part-time with us, and in the very near future, full-time. And once you've finished your BSc degree, you then go straight into a master's degree, after which you'll be able to go out into industry as an engineer. And this is quite important, and I'll mention that again later, about the bachelor degree is a 3-year BSc Engineering Technologist degree. Once you've done that 3-year degree, full-time equivalent, you do your 2-year master's degree, which then takes you up to a professional engineer level. If you're a trade certificate holder or a diploma student, you've got two options. You can either go straight into an advanced diploma and exit here as a technician. So that's a nice exit point after about 18 months. You continue on into a bachelor degree because you get credit for a whole heap of units, and then you can exit after that degree. Or you can simply go straight into a bachelor degree and then move on into a master's degree afterwards. So that's pretty much how the pathways are set up to make it easy for you to get in and get out wherever you feel like it. Because it's important that you progress through the course gradually. So the bachelor degree, you get a 3-year engineering technologist degree. And so the question might be, well, what's the difference between the 3-year and the 4-year? Well, the 3-year degree that we've got set up here is equivalent to a 3-year engineering technologist degree without the honors year. The honors year we essentially built into our master degrees. So that means you do your 3-year bachelor degree and then you move into the master's degree, which takes you only 2 years, and then you exit with a master's degree. So you get into a job quicker because after 3 years, you hop into a job. And it also takes you one step further because on top of that, you add on a master degree. And that's what we call a 3+2 model. 3-year bachelor degree, 2-year master's degree, and it allows you to be financially better off because you get to work sooner, especially if you're doing it full-time. And it's also far more intense and skills-based. So you get a lot more applied skills during your study. We've got the fields of industrial automation, electrical, mechanical, civil and structural engineering currently running. So those 4 streams are the bachelor degrees that we offer. In order to get into the bachelor's degree, you need to have a year 12 or equivalent with mathematics. That's part of the entrance requirements. If you do not meet those entrance requirements, for example, you have a trade skill, that's okay. Get in touch with us. We're more than happy to guide you and perhaps guide you towards an advanced diploma, which is an articulation pathway into this bachelor's as well. So definitely get in touch if you are unsure whether you meet the entrance requirements. You need to spend about 10 hours per unit per week, so it's not too extreme. And we've got about 26 units over the duration of this BSc degree with a final project, which is quite exciting. You've got readings, exams, remote labs, all set up for you. And you've got the support officer all the way through guiding you as you go. Then for the master's degree, if you're interested, let's say you've already got a bachelor's degree and you want to head on into a master's degree, what do you need? Well, you need a 3-year BSc degree to get into our master's degree. The BSc degree should at least have about 6 to 12 weeks work experience required in it in order to get you in. But if you've got a bachelor's degree and you've worked for many years, well, that's it, you're in. It's pretty straightforward. And you've got 12 units with a capstone thesis unit. And that's pretty impressive stuff that we've seen from our master's degree students as well. So it's exciting because you can work on this in 2 years part-time. So it's full-time or equivalent, but it's essentially a part-time course, meaning you can study from home or work after hours, and it takes you 2 years to complete. You can also study this 2 years full-time on campus here in Perth, and that takes you 2 years as well, but it runs on a typical semester model. If you study online, you can start in January and you can go all the way through to December. Whereas if you study on campus, it's a classic semester model here in Perth. Beautiful campus. Go to our website, check it out. The photos are just fantastic. We love that place. It's an excellent space. For the masters, you'd need around 3 structured hours of lessons where you actually attend classes or lessons online, and you've got a whole bunch of self-study time required, which is typical of a master's degree. And the same as all the bachelors, you've got readings, assessments, and once again, that learning support officer that guides you all the way through. So I mentioned the library earlier, so we've got a whole range of possibilities for you to use. So you've got the Elsevier Novel Library, IEEE Explore, which is a fantastic library. It's globally recognized and it's a massive collection of journals. So that's all available to you as students free of charge. And it's online, so you can get access whenever you need. And we've also got a whole bunch of technical manuals available for you. We've also got membership with some of the private higher education departments out there, and they all assist us with resources. It's fantastic stuff that we're doing. And our lecturers are global, and they know their stuff. So you'll be in good hands. So it's important to not compromise on the quality of your education. You have to demand the best for yourself, because this is your future that we're talking about. And in a technical field, you are definitely geared and set up for success. And a lot of institutes out there are quite amateurish, and we believe we do a professional job, and our students echo that statement. E-learning is the new kid on the block, and it's proven highly successful, and it is the way of the future. I'm not saying that a classroom-based system is not working. It's a fantastic model, but e-learning and live online is just as efficient and good as a classroom-based course. Quality lecturers and instructors are important, as I mentioned. They've got to have the passion for it. Otherwise, you're just sitting in another boring old lecture. So our material is not just a book on the web. It's interactive. It's there to teach you real skills. It's worldwide reach, and it's important. With that, I'll wrap up the session and open the floor to any questions. If there's any specific information you want me to elaborate on again, please let me know, and I'll go back to the previous slides. So any questions, feel free to either type them out in the chat space to your left, or if you're on the mobile phone, to the top, or I'll hand over the microphone, and you're welcome to click the little talk button and ask a question or two if you want to. So with that, I'll give a few seconds for any questions. Any questions?
Thanks for that, Steve. While we wait for any questions to trickle through, if there are any, I'll just add in a little bit here. So I will be sending through the recording to everybody. And if you think of any questions later on, or if you'd like to know more about a particular course, you can simply respond to that email. My name is Shanae, and I will put one of our course advisors in touch with you. So just let us know which of the courses you're interested in, and someone will be in touch with you soon after you inquire.
Thank you, Shanae. So any other questions? I'll quickly hand over the microphone.
Hello.
Hi, Adam. I think, Adam, I heard some of your audio come through. You're welcome to ask the question. I can't seem to be hearing your question, Adam. In the meantime, I'll just quickly touch on Ree's question on do students get any software to play with offline? Yes, in a lot of the cases you do. We actually go with a lot of open source solutions, so you can download it yourself and play around with it. And we guide you. And because you're a student with us, you also get student discounts on a lot of the corporate and industrial packages, so that's quite useful. And the remote labs are set up in such a way that you just go to a website, you click connect to the lab, and your whole screen then essentially becomes the desktop computer of the remote lab. So if there's a software package that's quite expensive, we procure that, install it, and get it set up on our remote labs for you to access and to play with. So yes, definitely. We also send out a whole bunch of links to free software for our students to download and play with, because it's all based on what's out there in the industry and what's being used. So any other questions? I'll hand over the microphone again. So if you wish to ask using the microphone, just click the microphone button and go away and go ahead and talk. Hi, Dylan. I see there's a question on the maximum time allowed for exemptions if the student has completed level 6 qualification in UK. So I'm not sure if I understand what you mean by time allowed for exemptions. Perhaps if you're referring to credit being awarded for a bachelor's, we work on an RPL system. So if you enroll in the course and you feel that you've already covered a lot of the materials, you're welcome to apply for RPL, which will allow us to do an assessment and offer you credit in some of the units, especially if the units you've studied elsewhere. You'll then get credit for those units. And if you're talking about how much time you'll get because of that, it depends on the RPL. If you get 3 units credit, then it reduces your study load by the 3 units, or if you get 6 units, and so forth. So it's all dynamic, depending on how many units you get credit for, or exemptions for. It also depends on the level of your qualification. I hope I answered your question, Dulanjaya. Any other questions? Excellent. Glad I could help. So the question from Rui is, do we also offer BSc degree on campus in Perth? Well, we have applied to get that active for next year, Rui. So it's definitely it's on the cards, and it'll be in the same campus as our master degree students. So it is definitely on the cards there. And I think the most important thing to do is to get in touch with our course advisors, and they'll have a chat with you and explain the whole setup, but maybe give you some more information on that as well. The fee for the on-campus is calculated differently, but the course advisors will be able to guide you. So go to our website and give us a call or send us an email, and our course advisors will be more than happy to get in touch and guide you. So we are quite excited on going ahead with our BSc and other master degrees on campus, and it's a beautiful place here in Perth, and the campus is also fantastic. So once that's up and running, you'll be the first to know for the bachelor's degree. The master's degrees are going ahead on campus, so they're already running, and you're more than welcome to join the master's levels. Bachelor degrees coming soon, so please get in touch, and we'll keep you posted. Any other questions? So are there any credit requirements to attend online class? I'm not entirely sure what you mean by the question, Ree. If you enrolled in the online bachelor's degree, then if you've got a year 12, then you're in. And even if you've done a prior qualification, you can also apply for RPL or credit for certain units to be given, meaning you don't have to do that unit because you've studied it elsewhere. So there's a question from Dilunjaya about the course fees. So the course advisors would be the best people to talk to, because I believe we've got fees for different regions. And depending on the region you're from, the fees will be calculated according to your currency that you're paying in as well. So about discounts, I cannot give you an answer there. The idea will be to talk to the course advisors, and they'll be able to sort something out for you and maybe have a chat. And we're always open to talking to students about scholarships and things like that. So please feel free to get in touch with us and mention the conversation we had here, and we'll see what we can sort out for you, Dylan. Any other questions? So if you're enrolled with us, Rui, and you attend the online classes, that is your degree. That's what you do. You don't have to go to a physical campus if you're enrolled in the online degree, because every time you attend the online class, that goes towards your degree. And once you've done all the required classes, you over the 3 to 5 years, depending on whether you study part-time, you will then be awarded a degree if you've passed those units. So if you study on campus, that's different. If you study with us and you plan to go to another university, it's a case of that university accepting whatever we've delivered as part of their equivalent units. But because we are an accredited Australian education provider, whatever we deliver would be at the correct level internationally. So, yeah. Oh, so if you go offshore, that's not a problem, right? Then what you do is the online sessions are also recorded, so you can always get access to the recording. You'll have to review that recording and submit a paragraph to the learning support officer just to prove that you've actually listened to the recording, because sometimes there's some questions in there that you might have to answer, but it's all recorded and you still get access to it, even if you are offshore. So that won't be a problem at all. As a matter of fact, a whole lot of our students are FIFO students, so they fly in, fly out, and if they miss a class year, they get opportunity to attend another one, or they can watch the recording and submit the specific requirements or questions and answers from that recording. So that will definitely not be a problem. So if you attend the online classes, you'll definitely get credit towards your course. There's a question from Dylan Jaya on how the practicals will be done. So the practicals you do via remote labs. So what I'll do is I'll quickly bounce to the slide on the remote labs, just to explain once again. So Dylan Jaya, what happens is, let's say we've got a practical assignment that requires you to develop a bit of code for a PLC system, which is a programmable logic controller. And that PLC code you then need to upload or download to an actual PLC and see what it does. So what you do is the assignment then tells you, go to EIT's Remote Lab 10, which is based here in Perth. And let's say you're based in the United Kingdom. So you go to the website, you connect to the remote lab, which essentially takes up your whole screen, your full browser screen. No worries. I don't mind explaining. I'll go over it again. No worries. So it'll take over your whole screen on your computer with the desktop view of that lab. And once you're in that lab, you can then go ahead and actually control the aspect. So here's a photo where you get access to, say, that desktop computer there remotely. You can then see on the webcams, the hardware that's connected to it. And let's say you've uploaded code to a PLC. Via the webcam, you'll then be able to see the traffic lights or whichever part of the practical is required to run. And you can then take screenshots of that and submit that as part of your practicals. We've got practicals with PLCs, with level motion sensors, 3D printers. We've even got a new robotics kit that we're setting up where you control a robot arm and you need to position it using control systems, and it's all fantastic stuff. And that's even better as well. The practicals might also ask you to do simulations. So you once again connect to a computer here that's running industry-grade simulation software, and such as MATLAB and SolidWorks, and you can then play around with that and complete the practicals via our labs. In most cases, we also offer you with software that you can use in your own computer at home or work, wherever you are based, so that you can do it on your own computer. But sometimes your company policy might not allow you to install software, or your computer is not powerful enough to run it. Then the remote labs are ideal to run your simulation software or processing calculations, etc. So you essentially do all the practicals online. You connect to our remote labs and you complete the practical there. And our practicals are set up in such a way that you would be able to do it using the remote labs only. So whether you study online or on campus, you get exactly the same experience. I hope that answered your question, Dylan. Alrighty. So with that, I'll Because there's a question from Rui on how the exam works. For example, calculations, do we do them online as well? All right, so that's a very interesting question, Rui. So what we do is the exams are all proctored or invigilated remotely. So we've got a piece of software that you run in your browser, and that records you while doing the exam. So that's a way for us to ensure the exam integrity is upheld. Now, the exam paper is sent out via the learner management system, which you get access to. You go through the paper, you've, say, got 3 hours or so to complete the exam. You then, if it's a multi-choice questionnaire type exam, you complete it online. Or if it's a problem-based exam, you'd, for example, have a few sheets of paper that you can do your calculations on and work out the various problems until you get the solution. You then enter the solution online. Once you've finished the exam, you submit the online paper and you just submit a scanned copy of your workings the next day. Your online submission is the submission that counts, and the workings that you submit would essentially be as supporting evidence of the exam. What's interesting about our exams, though, is that pretty much all of them are open book exams. That's great. That means you get resources to use while doing the exams, because that's also real engineering out there. That's the real world out there. You have resources to help you in solving the problems in front of you. So that's something we find is quite valuable. So the calculations you do on paper, you submit the final answer online, and you then scan a copy of your workings to support your final answer. I hope that answers your question, Rui. Happy to help. If there are no further questions, I'll wrap up the session, and I'd like to thank you all for attending. I'm happy to see that we've got a very interactive audience, and thank you everyone for attending, and Carol for assisting with the recording. Much appreciated. With that, I'll wrap up the session, and thank you all for coming, and I hope you have a lovely day, evening, and or morning. Thank you, everyone. Have a good day. Bye-bye.
Thank you.